Hello good people, I'm going to continue talking about molecular shapes. And once more, I'm going to use the molecular geometry software from the good people at the University of Colorado Boulder. I'm going to start with a diatomic molecule. Let's say hydrogen chloride. Imagine that the purple sphere is a chlorine atom. I'm going to add a hydrogen to it. And here it is. The white sphere represents a hydrogen atom, and the white line between the two spheres represents a pair of bonding electrons. Recall that any diatomic molecule will have a linear molecular geometry. Let's test that. I invite you to draw the Lewis dot structure of hydrogen chloride. Have you done it? Good. Note that chlorine has 4 pairs of electrons. There is 1 bonding pair and 3 non-bonding pairs. I am now going to add the 3 non-bonding pairs of electrons. Here's 1, 2, and 3. The molecular geometry has not changed. The molecule is still linear. However, the electron geometry is tetrahedral. The electrons, bonding and non-bonding, are arranged in such a way as to be as far apart from each other as possible. So even though the molecule is linear, the electron geometry is tetrahedral. What happens if we have a polyatomic molecule, such as water, H2O? Imagine that the purple sphere is the single oxygen atom. I'm going to introduce the 2 hydrogen atoms, 1 and 2. Currently, our water molecule is linear. However, that is not the case. I have forgotten something. If you draw the Lewis dot structure of water, you will notice that the oxygen has 4 pairs of electrons surrounding it. 2 of those pairs are the bonding electrons, but there are also 2 pairs of non-bonding electrons. So let me add the non-bonding electron pairs. Here's one, and here's the second one. What is the shape now? Well, in terms of the electron geometry, we have a tetrahedral system. Or more precisely, the electron pairs, bonding and non-bonding, are arranged in a tetrahedral fashion. What of the molecule itself? Well, the molecule is bent. Out of curiosity, what would happen if I only had 1 lone pair of electrons? Well, let me remove one of the 2. The molecule is still bent, but the electron geometry now is trigonal planar. The electron pairs are arranging themselves so as to be as far apart from each other as possible. Let me do another reset. The next molecule I would like to model is boron trihydride. Boron is surrounded by 3 electron pairs. In case of boron trihydride, all 3 pairs are bonding pairs. In other words, each pair serves as a covalent bond between boron and hydrogen. So let me add in those 3 hydrogens. 1, 2, and 3. The electron geometry is trigonal planar, so is the molecular geometry. All of the atoms are in the same plane. How does boron trihydride differ from ammonia? Recall, ammonia is NH3. If you were to draw the Lewis dot structure of ammonia, you will notice that the nitrogen in the center is surrounded by 4 pairs of electrons. 3 of those are bonding, but there is also a non-bonding pair of electrons. So I'm going to add that one. And here it is. How has the molecule changed? Well, in terms of the geometry, the molecule is pyramidal. However, the electron geometry is tetrahedral. The bonding and non-bonding pairs of electrons have arranged themselves so as to be as far apart from each other as possible. Out of curiosity, let's add another lone pair of electrons. Here it is. The electron geometry is trigonal bipyramidal. However, the shape of the molecule is T-shaped. Not very imaginative, but that is exactly what it looks like. Let's push this a little bit further. I'm going to add another lone pair of electrons. The molecule is still T-shaped, however, the electron geometry now is octahedral. The 6 pairs of electrons are arranged in such a fashion as to be as far apart from each other as possible. Let's do another reset. This time I'm going to look at methane. Methane has a formula of CH4. The purple sphere represents the carbon in the center, and now I'm going to add 4 hydrogens. 1, 2, 3, and 4. Both the electron and molecular geometries are tetrahedral. Carbon does not have a lone pair of electrons that will influence the shape of the molecule any further. But what would happen if we were to add a lone pair? Well, here it is. The electron geometry now is trigonal bipyramidal. The molecular geometry is seesaw. Let me add another non-bonding pair of electrons. Here it is. The electron geometry is now octahedral, while the molecular geometry is square planar. The atoms are arranged in a square, and they are all in the same plane. In summary, the bonding and non-bonding pairs of electrons arrange themselves so as to be as far apart from each other as possible. This will give the electron geometry. The electron geometry, in turn, will influence the molecular geometry. A tetrahedral electron geometry can result in the bent molecular geometry of water, pyramidal geometry of ammonia, or tetrahedral geometry of methane. That is all for now, and I will see you on the flip side.